Hello everyone. Today I am going to discuss the fourth problem of Codeforces round 929 division 3, which is turtle tenacity continual mods. So what is the problem? We are given an array a of n integers. Now we can rearrange the array and form another array b, and we have to take this formula b1 modulo b2 till bn. Okay, now what we have to determine if this formula is not zero or not. We can rearrange in such a way that this thing is non-zero. If it is possible, then we have to print yes, otherwise we have to print no. So this problem I find it a bit difficult than other division 3 Ds, but there are many test cases. I think that will help us to understand what the solution is. So let's take one example, this example only. uh, Let me write this here. So we have six integers from 1 to 6. Okay, now we have to rearrange them in such a way such that one b1 modulo b2 like that till bn is non-zero. Now let's take in the same order. So let us take 1 modulo t2, which will be 1. Now this thing modulo 3, which will be 1 modulo 3, which will be 1. Now 1 modulo 4 1, like that the answer up till 1 modulo 6 will be 1. So the answer is not 0, so answer is definitely possible, so our answer will be yes, and we don't have to rearrange them. The order that is given in the array, we can use same order for b. Okay, now let's take another example. Let's take all threes, the second case, all threes. Okay, now if they're all threes 3 3 3 3 3, we can't rearrange them in any way such that b1 modulo b2 is non-zero, because let us take 3 modulo 3, this is becoming 0. Okay, so if we take 0 modulo 3, it will be 0 again. Okay, so there is no possible way to rearrange them, and so our answer will be no. Now let's take the third case. The third case is also important, so let's write this case 2 2 3. Okay, 2 2 3. If we don't shuffle them or don't rearrange them, and we use the same order like 2 modulo 2, it will be 0, and 0 modulo 3 will also be 0, so the answer will be no. But we can rearrange them in this way. Let's say 3 2 2. Okay, if we rearrange them 3 2 2, 3 modulo 2 will be what? 3 modulo 2 will be our 1, and 1 modulo 2 will be 1. So if we rearrange them in this way, the answer will be yes, so our answer is yes. Now you can check the other examples as well. Now I will jump into the solution approach or some observations we can do. Okay, now the first thing that came to my mind is that obviously let's discuss the time complexity first. Here t is 10 to the power 4 and sum of n is 2 into 10 to the power 5, and on the constants on ai is 10 to the power 9. So overall time complexity could be order of n or order of n log n, and it's possible also that order of n log ai, this time complexity is also possible in log ai. Okay, now here this is the time complexity. Now what is the first observation that came to my mind? Not observation, but I thought that that could be one possible solution. I thought that, let's say, the what is the frequency of minimum element. Let's say if the frequency of minimum element is greater than 1, then the answer is not possible. But that case is getting I think this will not work with this case, because the minimum element frequency is 2, and the answer is yes. So that solution approach is gone. Now we have to think in some different direction. Okay, so I thought in the direction of using GCD. Okay, GCD, because the GCD of all these elements is 1. Okay, here, so the answer is yes. Now you check the test cases. The GCD of all these elements is 1, answer is yes. Here GCD of all these elements is 3, answer is no. Here the GCD of all element is 1, answer is yes. But the I am thinking about that if GCD is 1, answer will be yes, and otherwise the answer will be no. But in this case, okay, in this case the GCD is 1, but the answer is sorry, in this case the GCD is 1, but the answer is no. So our that approach also breaks here. So we have to think about something more. Okay, so what I thought is that if the frequency of GCD is greater than 1, then our answer will be no. and if the GCD frequency of GCD is less than 1, then the our answer will be yes. Okay, and that turns out to be the correct idea. Now I will explain that how this idea works. Okay, now from Euclidean algorithm, you know that GCD of a comma b is same as GCD of a modulo b comma b. Okay, GCD of a modulo b comma b. So if we arrange if we arrange them in any order, the elements, like if we arrange the element of ai, a1, a2 in any order, the maximum value that comes to be is obviously GCD of the array. Okay, the maximum value of the arrangement and the formula, the formula like a1 modulo a2 will be GCD of a. Okay, now there comes a case when how we are arranging this, right? So let's say a comma b. So how we are going to arrange them? Let's say we have taken the two elements a1 a2, and the a1 modulo a2 is obviously should be divisible by GCD of a1 a2, right? This is the Euclidean algorithm, that a1 modulo a2 should be divisible by GCD of a1 comma a2. Now we will check that what is the value of this a1 modulo a2. Now we'll take this as the third value. Let's call it as b3, or let's call it as k. Okay, now we'll check that if a3, if a3 is greater than k. So let me write, if a3 is greater than k, we'll take a3 modulo k, else we will take k modulo a3. Like that we will arrange the array elements in such a way that the arrangement will give us GCD of a. But this will fail when there is already there is two GCD present in the array. Let's say there is G and G present in the array. Let's consider the case, let me delete all these things. Now let's say only one GCD is present in the array. So let's say G, A, A2, A3, like that. Now what we will do, we will take G modulo A2 modulo A3 like that, and we will get at the end we will get G. Okay, now if there are two G's present, so we can't take anything, right? We can't take anything, right? Let's say we are arranging something, so the value will be our G, and after that we will do G modulo G, and our answer will be 0. So if two G's or two or more G's are present in the array, then our answer will be 0. And otherwise we can arrange them in this order, like I have explained you, that if a3 is greater than k, we will do a3 modulo k, else we will do k modulo a3. We will arrange in such order, we will get our G, the value a1 modulo a2 modulo a3 as G. Okay, I hope you got the solution. The code is quite straightforward. We are taking the GCD of all the elements of the array, and if the count of GCD in the array is less than equals to 1, we are printing yes, otherwise we are printing no. I hope you get the solution. There is some math involved in the problem. You have to know what Euclidean algorithm is, and this formula, that GCD of a comma b is GCD of a modulo b comma b, and we are using this formula. And the second observation is that the maximum value we can get by rearranging them is GCD of a. Okay, uh, I will provide the link of the code in the description box. If you have any doubt in any part of the explanation, you can always ask in the comment section. I will try to reply each and every comment. Please like the video and subscribe to my channel. Thank you.